Abstraction mechanisms. Concrete types. The basic idea of concrete classes is that they behave just like built-in types. For example, a complex number type and an infinite precision integer are much like built-in int, except of course that they have their own semantics and sets of operations. Similarly, a vector and a string are much like built-in arrays, except that they are better behaved. The defining characteristic of a concrete type is that its representation is part of its definition. In many important cases, such as a vector, that representation is only one or more pointers to more data stored elsewhere, but it is present in each object of a concrete class. That allows implementations to be optimally efficient in time and space. In particular, it allows us to place objects of concrete types on the stack, in statically allocated memory, and in other objects. Refer to objects directly, and not just through pointers or references. Initialize objects immediately and completely, example, using constructors, and copy objects. The representation can be private, as it is for vector, and accessible only through the member functions, but it is present. Therefore, if the representation changes in any significant way, a user must recompile. This is the price to pay for having concrete types behave exactly like built-in types. For types that don't change often, and where local variables provide much-needed clarity and efficiency, this is acceptable and often ideal. To increase flexibility, a concrete type can keep major parts of its representation on the free store, dynamic memory, heap, and access them through the part stored in the class object itself. That's the way vector and string are implemented. They can be considered resource handles with carefully crafted interfaces. Thank you for watching.